You check your phone for the date without thinking about it. A number, a month, a year. It feels solid. It feels obvious. But the system behind that number is younger than you assume, and shakier than you assume. By the end of this video, you'll understand why a calendar built thousands of years ago, with no telescopes and no satellites, landed closer to the true length of a year than tools you trust today ever could on their own. That gap should not exist, and yet it does. Start with something simple. A year is just the time it takes Earth to circle the sun. You learned that in school. It sounds settled. But ask yourself a harder question. How long exactly is that trip? Not roughly. Exactly. Down to the minute. Down to the second. Most people alive today could not answer that question without pulling out a device. Ancient astronomers in India answered it with nothing but eyes, shadows, and centuries of patient counting. Here is the number modern science accepts. A tropical year is approximately 365,24219 days. NASA's own reference models converge on that figure today, refined by satellites, atomic clocks, and decades of orbital data. Now here's the strange part. A text called the Surya Siddhanta, an ancient Indian astronomical treatise whose surviving form dates back roughly 500 years, gives a year length of 365,587 days. Close. Startlingly close. Off by a fraction most people would never notice in a lifetime. Pause on that. This was not guesswork. It could not have been guesswork. Because guesswork does not consistently land within minutes of a value that would not be independently confirmed for over 1,000 years. Something else was happening. What tools did they have? What method could get you that close without a single satellite in the sky? The answer sits inside the discipline itself. Vedic astronomy, known as Jyotisha, was not separate from ritual life. It was built into it. Priests needed to know exactly when solstices fell, when eclipses would strike, when the monsoon should arrive, because ritual timing and agricultural survival depended on it. That pressure created something rare, centuries of continuous obsessive, generational observation. Not one lifetime of counting, dozens of lifetimes handed forward. Consider Aryabhata, a mathematician and astronomer working in the 5th century. He calculated the length of a sidereal year, the time Earth takes to return to the same position relative to the fixed stars, at 365.25858 days. Modern instruments place that figure at 365.56636 days. The difference is a matter of minutes, achieved with no lens, no glass, no electricity. He also proposed that Earth rotates on its axis, an idea that unsettled some of his contemporaries, because it meant the sky was not moving. Here's where it gets stranger. This was not an isolated success. Centuries later, an astronomer named Bhaskaracharya refined similar calculations further, working through orbital mechanics and time divisions with a precision that still surprises historians of science today. David Pingree, a historian who spent much of his career studying the history of Indian astronomy, spent decades tracing how these calculations moved between India, the Islamic world, and eventually Europe. His research shows something most textbooks skip entirely. Ancient Indian astronomical methods didn't just exist in isolation. They traveled, they influenced, they shaped tools other civilizations later claimed as their own discoveries. So why does almost nobody learn this? Why does the popular story of astronomy skip straight from ancient Greece to Galileo, as if 1,000 years in between produced nothing? Part of the answer is uncomfortable. Written knowledge that wasn't preserved in Latin or translated early into European languages was, for centuries, simply left out of the dominant narrative. Not because it was wrong, because it was inconvenient to the story being told. Carl Sagan, in his original Cosmos series, pointed to Hindu cosmological time scales, cycles measured in billions of years, as strikingly close to the actual age of the universe, at a moment when most Western religious traditions were still working with time scales measured in thousands of years. He wasn't being sentimental about it. He was pointing out a mathematical coincidence too large to ignore. Now hold that thought, because here is the twist that changes how you should read all of this. These numbers weren't perfect. The Surya Siddhanta wasn't handed down flawless from the start. It went through revisions. Different regional schools of Jyotisha produced slightly different values. Some were more accurate than others. This wasn't divine transmission. It was refinement. Generation after generation, astronomers noticed small errors accumulating over decades of festivals landing on the wrong day, and they corrected the model. That is not mysticism. That is the scientific method, running quietly for over 1,000 years, without ever being called that. And that reframes the entire question you started with. It's tempting to hear, an ancient civilization predicted time better than modern science, and imagine something mystical. Lost wisdom, secret knowledge from the stars. But look at what actually produced these numbers. Patience, repetition, willingness to be wrong and correct course. Careful observation treated as sacred, not because it flattered anyone's ego, but because getting it wrong had real consequences for real people. That is the part almost nobody talks about. The Vedic astronomers who nailed down the length of a year weren't chasing perfection. They were chasing consistency, because a wrong calendar meant a wrong harvest, a wrong ritual, a wrong season. Precision wasn't a luxury for them. It was survival. And that pressure, sustained across centuries, produced numbers that satellites would later confirm. So think about your own relationship with time for a second. You open an app and get a date instantly. No effort, no cost, no consequence if it's wrong by a few minutes. That convenience has quietly erased the instinct that built civilizations like this one. The instinct to actually watch, to track something over years, not seconds, to notice a small drift and ask why instead of assuming the tool in your pocket is simply correct. Here's the part worth sitting with. The next time your phone tells you the date, remember that number rests on a foundation laid by people staring at shadows for their entire lives, correcting their own mistakes decade after decade, so that one day, a civilization with satellites in orbit would check their work and find it startlingly close to true. But there's a second layer to this story that most people miss entirely, and it has nothing to do with the length of a year. Go back further than Aryabhata. Go back to a much older text called the Vedanga Jyotisha, one of the earliest surviving Indian works dedicated purely to timekeeping, composed sometime in the final centuries before the Common Era. Its concern wasn't philosophy. It wasn't myth. It was a practical problem. The sun's calendar and the moon's calendar do not line up. A solar year runs roughly 365 days. 12 lunar months run closer to 354. That gap, left uncorrected, means your festivals slowly drift out of season, year after year, until a harvest celebration lands in the middle of winter. You might recognize this exact problem from somewhere else. The ancient Greek astronomer Meton solved a version of it in the 5th century BCE, with what's now called the Metonic cycle, a 19-year pattern still used today to calculate the date of Easter. What rarely gets mentioned in that story is that Indian astronomers were wrestling with the same lunar, solar mismatch, using their own intercalation methods, on a similar timescale, independently. Two civilizations, no contact, converging on the same kind of fix because the sky gives everyone the same problem to solve. That should make you pause. This wasn't one culture borrowing from another. This was two separate groups of humans watching the same moon, the same sun, and arriving at strikingly compatible solutions through nothing but careful counting. Convergence like that is rare. It usually means the underlying method was sound. Now here's a pattern interrupt worth sitting with. Ask yourself, what would it take for you, right now, with no phone, no internet, no reference book, to figure out how long a year actually is? Could you do it in a year, 10 years, a lifetime? The honest answer for most people is no. Not because you're less capable, because you've never had to build that muscle. The ancient Jyotisha tradition built it across not one lifetime, but dozens, each generation checking the last one's work against the sky itself. That obsession with checking and rechecking eventually produced something even more startling than a year length. It produced eclipse prediction. Indian astronomers developed methods to forecast both solar and lunar eclipses years in advance, using models of the moon's node cycle. The slow, wobbling path where the moon's orbit crosses the sun's apparent path, the exact mechanism that determines when an eclipse can even occur. Get that calculation wrong by a small margin, and your predicted eclipse simply doesn't happen. Get it right consistently across centuries, and you've proven your model of the sky actually works, not just once, but reliably. This is where Bhaskaracharya Toe becomes impossible to ignore. Working in the 12th century, he didn't just refine year-length calculations. In his major work, he described instantaneous motion in ways that anticipate core ideas behind differential calculus, centuries before Newton and Leibniz would formalize calculus in Europe. He also wrote about gravity as a force pulling objects toward Earth, describing it in terms that read almost eerily close to a modern physics textbook, long before anyone in Europe framed the idea that way. None of this means ancient India invented modern science, in some final, settled form. That would be its own kind of distortion, just in the opposite direction. What it means is narrower, and in some ways more interesting, rigorous, testable, corrected. Over time, observation was happening in multiple places on Earth long before Europe's scientific revolution, and one of the richest, longest unbroken threads of it ran straight through Indian astronomy. So why did this thread nearly vanish from the story most people are taught? Part of it comes down to translation and timing, the same issue David Pingree's research kept surfacing. Sanskrit astronomical texts moved slowly into other languages, filtered first through Persian and Arabic scholarship during the medieval period, then later into Latin, often stripped of clear attribution by the time European scholars encountered the ideas secondhand. By the time a global history of science narrative got written down in the 19th century, mostly by European historians working from European sources, the Indian half of the story had already been quietly cropped out of frame. Not disproven. Cropped. That's the twist worth holding on to. This was never really a story about lost, mystical wisdom waiting to be rediscovered. It's a story about careful, patient, corrected observation run for over 1,000 years that got written out of the popular record for reasons that have nothing to do with whether it was accurate. Now bring that back to you, sitting here, checking a screen for the date. You never have to notice a seasonal drift. You never have to watch the sky for years to catch a small error creeping into your calendar. Every correction has already been made for you, invisibly, by a chain of people going back centuries, some of whom you now know by name: Aryabhata, Bhaskaracharya, the unnamed generations behind the Vedanga Jyotisha and the Surya Siddhanta, patiently checking their ancestors' math against the actual sky, one solstice at a time. That's the real trade you've made without realizing it. Total convenience, in exchange for total disconnection from the process that made the convenience possible. Your calendar app has never once been wrong in your lifetime. And because it's never been wrong, you've never had a reason to ask why it's right. Here's the part worth sitting with. The next time your phone tells you the date, remember that number rests on a foundation laid by people staring at shadows for their entire lives, correcting their own mistakes decade after decade, checking eclipses against a wobbling moon, so that one day, a civilization with satellites in orbit would check their work and find it startlingly close to true. You checked your phone for the date without thinking about it. Maybe now you will.